Hello, good day viewers. I have wanted to introduce indefinite integral from definition, but I realize it is very important to know how to express series into sigma notation and also knowing how to evaluate a sigma notation. We have some series here. We have 3 problems in this tutorial. We would like to express this, and this into a summation form. And how can we do that? It is very important because we are coming to that when we started dealing with definite integrals from definition. All right, to do this, you have to always examine the nature of the series given to you. Let's start with the first one. We have 7 plus 9 plus 11 plus up to 99. If you look carefully, this is an arithmetic series. Why? Because we have a constant common difference of 2, right? 7 plus 2 is 9, 9 plus 2 is 11, plus 2 I think is 13, plus 2 is 15, up to 99. So since we have realized this is an arithmetic series, we can come up with a formula that defines every single term. And what is that formula? Tn is equal to A plus n minus 1 multiplied by d. Remember, this is n term of arithmetic sequence. So we can use this to define every single term. Then we take the summation from 0 to a certain number because we have to find a particular number here. But from the question, we want n to start from 0. All right. A is always the first term, which is given as 7 plus. We don't know what is n, the number of terms, but the constant common difference is 2. 9 minus 7 is 2. 11 minus 9 is 2. So we have 2 right here. This is 7 plus n times 2 is 2n. Negative 1 times 2 is negative 2. And you can see that 7 minus 2 is 5. So we have 2n plus 5. But the question is, will this satisfy our sigma notation? What happens if n is 0? Because when n is 0, we have to obtain the first term. When n is 0, we have 7. So will this evaluate to 7 if we plug in 0? Let's test it. When n is 0, we have 0 times 2 is 0, plus 5 is equal to 5. And our first term is not 5. But I told you this defines every single term. But since we realize this is equal to 5, we can confidently replace 5 with 7 because it will satisfy. Let me show you. If we have 2n, instead of plus 5, we can write plus 7 because we know we are going to start with 0. But suppose we start with 1, it will satisfy. If n is 1, we have 1 times 2 is 2, and 2 plus 5 will give us the first term, which is 7. But since we want to start with initial value of 0, we can replace 2n plus 5 with 2n plus 7. So now it will satisfy. When n is 0, we have the whole of this to be 0 plus 7. It will give us this. Then the next time will be when n is equal to 1. We have 1 times 2 is 2, plus 7 is 9. You can see that here. When n is 2, we have 2 times 2, 4. And 4 plus 7 will give us 11. And in that order. So we can write it as 2n plus 7 here. This is the term. But what will be the last n value? Because n started with 0 and it has to stop with a particular value. And that value to the top will evaluate to 99. So we can confidently equate this to 99 to find out that value. If you take 7 to the other side, you have 99 minus 7, which is going to give us 92, right? 92. Then we divide both sides by 2, and that will give us 46. 46. Therefore, n start with 0 and stop at 46. And if you want to confirm, you can replace 46 with n here. We have 46 times 2, that is going to give us 92. And 92 plus 7 will give us 99. And hence, this is said to be the summation form of this series. And another way you can do that, let me see if it is applicable here. I can see that all these numbers are odd numbers, right? I know that 2n defines an even number. And the moment you add an odd number to an even number, you're going to get an odd number, because all of these numbers are odd numbers. So we have +1. This defines an odd number. But the moment you plug in 0 here, you have 1. But we want to get 7. So you replace this with 7 and it will satisfy. You see that? So let's take the second one. The second one, we have 5, 9, 13 plus after 53. This is also an arithmetic series because we have a constant common difference of 4. 5 plus 4 will give us this. 9 plus 4 will give us this. This plus 4 will give us next time up to 53. So we have Tn equal to A plus n minus 1 times D. This is not always the case. Sometimes you may get, what do we call it? Geometric progression and so on. So if A is 5 plus n minus 1, D is 4. We have 4 times n is 4n. Negative 1 times 4 is negative 4. We have plus 5 here. 5 minus 4 is 1. So we have 4n plus 1. So this is what we have. But let's see. When we plug in 0 here, we have 1. But our number is 5. So we can confidently change this to 4n plus 5 and test to see whether it works. If n is 0, we have the whole of this to be 0 plus 5 will give us 5. Then when n is 1, we have 1 times 4 is 4 plus 5 is 9, definitely. When n is 2, 4 times 2 is 8 and 8 plus 5 is 13. So this works. We have 4n plus 5. But what will be the last number? You can equate this, always you can equate it to the last digit, which is 53, to find the value of n. Once you take 5 to the other side, it is going to become negative. Then we have 53 minus 5, and that will give us 48. 4n is equal to 48. Then you divide both sides by 4. 48 divided by 4 will give us 12. N equal to 12. So we have to stop at 12. But I think the last one is the most simplest one. One thing about mathematics, you have to always think critically. To be a mathematician, you have to be a critical thinker. So one thing I come to realize about this series is that this 8 can be expressed as 1 times 8. This is what? 2 times 9. 3 times 10. Because I have seen a pattern. This is 49 times 56. Let me show you what I mean here. You see, 1 times 8. This 1 will increase to 2. This will increase to 9 to form another one. 1 divided by 2 multiplied by 9. Just observe. From 1 to 2. From 8 to 9. It will give us the above series. Plus 1 divided by 2 to 3. 9 to 10. Okay, you see that 3 times 10 will give us 30. This is what we're going to keep on having after the last one, which is 1 divided by 49 multiplied by 56. Another thing I can do here, I can write 8, 9, 10 up to 56 in terms of 7. Let me show you what I mean. This can also be written as 1 divided by 1 multiplied by 1 plus 7. See that? 8 is the same thing as 1 plus 7. Just look at this pattern. 2 multiplied by 2 plus 7. The number outside and the first digit inside the bracket will always be the same. 2, 2, 1, 1. Here we're going to have 3, 3. Just observe. You have to think critically. You see 3, 3. So the same thing, if you keep on moving after the last one, it will be 49 outside. Inside we have another 49 plus 7. Because 49 plus 7 is 56. And we have 49, 49. So we can confidently replace this repeating digit with n. So it will be summation of 1 divide by n multiplied by n plus 7. Can you see that? 1 plus 7. Because the moment you replace n with 1, it is going to give us this one, because it will be 1, 1. 1 plus 7 is 8. 8 times 1 is still 8. If you replace it with 2, we have 2 plus 7 is 9, and 9 times 2 is 18. You see that? So this is the pattern, and it is going to stop at n equal to 49. So this one is the most simplest one, 49. As simple as that. So we have this summation. So the moment you take this summation, it is going to give you this series back. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.